Here's integrated 3. It's 12-11. It says algebraically determine the points of intersection of y equals negative square root x plus 2 plus 5 and y equals square root x minus 3. So I see that I have two equations, and I see that they're both set equal to y, so I'm going to use the equal values method to find out where they intersect. So we know we can just set them equal to each other, and then find out what x is, and that'll tell us where they intersect, and then we can plug the x in and find out what y is. So what I did is I took this first one, and I plugged it in right here, and then I let the 5 go in front of the minus sign, so it looks like that. And now I'm just going to solve for x. I'm just going to use whatever algebra moves come to mind. I know that I have to get rid of the radical, so I'm going to square both sides. And that'll give me x minus 3. When I square something like this, I can put it on an area model box, and I'll get a trinomial out of this, or I know that there's a squaring pattern. It's this thing squared, the first thing squared, and then it's going to be 2 times the first thing times the second thing. So, and then the last term is going to be the second thing squared. So I think it'll be like that. And then I can clean it up. The 25 and the 2 can combine. So that's not too good looking, but I think I can cancel out my x's. And then I'm going to bring the 27 over here. So I think I'm going to have negative 30 over here. And then I'll divide both sides by negative 10. And then I can square both sides. And then I can subtract 2. So now I know x is 7. And if I plug that in to one of the original equations, like, well, actually I need to plug it in everywhere to make sure that it's really a solution. So 7 plus 2 is 9, and the square root of 9 is 3, and it's negative. So negative 3 plus 5 is 2. So let's make sure that this is also 2. 7 minus 3 is 4, and the square root of 4 is 2. So y equals 2. So I'm going to say that my answer is 7, 2.